All right, so we've got one problem to finish, you say, and that's going to be question number 8, right? All right. So let's go back and reread the directions so that we can remember what we're doing here. So 1 or more zeros are given. All right, the minute you read that phrase, the minute you read that sentence, what does that say to you? 1 or more zeros are given. Okay, yes, not what I'm looking for, but you're right. Same thing, not what I'm looking for, but you're right. Okay, not what I'm looking for, but you're right. It should go in evenly, not what I'm looking for, but you're right. It was a 2-word phrase that you have to do every time you're told 1 or more zeros are given. Say it again. Good 2 words. Prove it. Prove it. So the minute you're told that you've got zeros, go prove it. Okay, sorry, that's 3 words. But I just said prove it in last class. So prove that they are actually zeros. Now, you know that they're going to go in evenly. You know that they're going to be x-intercepts. You know that you're going to use synthetic division or substitution, whichever way you want to look at it. Okay, you know these things, and you know you're going to get a 0 remainder. Hey, if you get something other than a 0 remainder, what does that say to you? You did something wrong. You did something wrong. And it's not just that you might have, it's that it's an absolute. You absolutely did something wrong. Go do it again. Okay? You have to get a 0 remainder because, like I mentioned last class, I'm not going to lie to you. If I tell you it's a 0, it's truly a 0. Okay? All right, so let's jump down to number 8. Let me finish reading the directions here. So once you are told that some are given, go find the other ones. Okay? And then after we find all our zeros, then we'll factor and write it as a product of factors. Okay, so that's what we're being asked for on this one. Now look at number 8. How many zeros are possible in this particular polynomial? 4, okay? And we know that because of the degree, all right? And so we're supposed to, we've been given 2 of those zeros, so let's go prove it, okay? Which one do you want to choose first? Eeny, meeny, miny, mo, doesn't really matter, okay? Either way, we're going to land in the same place as long as you do your math correctly. So just simply because it's written first, we'll go with the 7 first. Okay, that's the best reason I got for choosing that one. So we're going to plug in 7. What are my coefficients here?
1, -5, and 1, -2.
There's a little bit of a lag, Becca. Sorry about that. Don't forget that you have missing terms. Okay, so the fact that you have a missing x cubed and the fact that you have a missing x to the first power says that you have to put zeros. Now, Sierra, I went back and watched that video. Did you get my email, my response? Yeah, so so that you can have a follow-up to the Sierra's question from last class. I went back to watch that video, and she did what Sierra said she did, and it's wrong. In fact, I have a meeting set up for next week with the Pearson rep, and I am going to point that out to her. Because it works in that problem because she was only plugging in the number 1. But if she had tried to plug in a 2, it would not have worked. So, Pearson is usually so good about things, it really surprises me that they didn't catch that. But anyway, I'm going to mention it to the rep and see what she says. Okay, so let's go ahead then, and we're in the process of proving our zeros. So we've got 1, 7, 7, 49, 50, 51, 52, so -3, -21, and then 7 times 2 is 14, 7 times 1 is 40. Yep, so -147. And again, we're not surprised by that 0. We're not surprised, okay? We would be surprised if we got something else. That would be a surprise. So let's go over to the side here and let's make a list of our zeros. So we just proved that x equals 7 is one of our zeros. We have a second zero that we need to prove. What I'm about to say is a big, big, big deal right now. Don't go back to the beginning. Don't go back to the beginning. Do you remember when we were doing the factor tree? This guy? We didn't go back to the 24 to keep factoring. We took our factors and we kept factoring our factors, right? That's the idea here. Remember from last class that this guy here, by the way, there's a fancy name for this. It's called the depressed polynomial. Oh, isn't that crazy? Yeah, and it has nothing to do with its emotional state, okay, or its mental state. It's depressed because it's low. It's down at the bottom, okay? So it's the depressed polynomial. This is what I'm going to use to prove the next zero, because this polynomial is a factor. Let me do this so people on Zoom can see me. This polynomial is a factor of my original polynomial. So it's like, instead of going all the way back to the 24, we're just going back to the 4 and we're factoring the 4. Okay, so go to the depressed polynomial. That's what we're going to use. So my depressed polynomial then is 1, 7, -3, -21. And now I'm going to test or prove my second zero, which is -7. 1, -7, 0, 0, -3, +21. And again, I shouldn't be surprised if there's a 0 remainder. God bless you. Now, what is my depressed polynomial now? What is my quotient now? Yeah, x squared minus 3. And you know what? Oops, x squared minus 3. That's a quadratic. So here's the deal. You want to keep on plugging in zeros until you get your quadratic. Why? Because we spent a whole chapter, chapter 3, working with quadratics. Okay, we know how to work with quadratics now. And so what we're going to do, notice that I didn't start out with a quadratic. I started out with a fourth power, a quartic. My first factored depressed polynomial was not a quartic. What was it? Yeah, it was a cubic, okay? And by the way, every time I pull something else out, every time I do synthetic division, I'm taking my degree down by another 1, okay? And so now I'm landing on this quadratic. We have 4 methods of solving quadratics, all right? So which method would you like to use for solving this quadratic? Totally the square root method. I've only got one variable sitting there. I can just get it by itself. Okay, so we'll add 3 to both sides, and then we'll take the square root of both sides, plus or minus, yeah, okay, and then now I have my other zeros. So we tested x equals -7, and we got a good 0 for that one. And then our final 2 zeros came from solving the quadratic, so that's an x equals √3, and an x equals -√3. Now, how many zeros did we expect from the very beginning? 4. Okay, so good, that checked out. Let's go back and look at the directions. 1 or more zeros are given. That statement means go prove it. We did. Find all the other ones. We did. Now we need to write it as a product of factors. We need to factor p of x. So just like we did on the last class, let's take our zeros and turn them into factors. So let's make another part of our chart here. All right, now let's go ahead, and the zeros are where x is alone. The factors are where the number goes over to be with the x. So what's my first factor? Okay, and somebody else, my second factor. X plus 7. Okay, a third person, the third factor.
X minus square root of 3.
Good, x minus the square root of 3. And then the last one, Dylan? Yeah. Did you see what you did there?
Yeah, I just did.
That's fine. And again, yes, I've made a list of my factors, but P of x is not in factored form yet. I have to write this as a product of my factors. So we've got P of x is equal to, we're going to multiply all of those factors together. So that's going to be x minus 7 quantity, x plus 7 quantity, x minus root 3 quantity, x plus root 3 quantity. Do you remember at the last class period, I told you to look for something? It was at the very end. Do you remember what I told you to look for? It was something in the original polynomial. Okay, you forgot. Oh, Devin, did you remember?
All the factors, first, like all the x's multiply together and equal the leading coefficient, then you don't have to check. Something like that.
Okay, your brain is thinking the right thing. The words aren't coming out quite right, but your brain is thinking the right thing. Yeah. Go to the original polynomial. What is the leading coefficient? 1. If I were to multiply, now we don't have to multiply, but if I were to multiply my factors together, what would the leading coefficient be? 1. They match, which means I don't have to do anything. Very shortly, they won't match, and I'll show you what to do. Okay, but as long as they match, as long as your leading coefficients match each other, you don't have to do anything. Okay? All right. I really wanted to do that question in class because of the fact that it was 2 zeros, and I wanted to point out how you don't go back to the beginning and plug into the original polynomial. You have to go to the depressed polynomial and plug it in there. Okay, so that's the big deal about that question. All right, 4-3. Okay, a couple of comments from the videos on 4-3. I want to look at little dude first. I gave you guys that on a sticky note. Little dude, first of all, is my own creation. It's not in your textbook. If you go to the TLC and you ask them about little dude, they're going to look at you like you grew 2 heads. They won't have a clue as to what you're talking about. I came up with this myself, okay, to help my students. You have 2 options. You can memorize little dude and it will make your life easier. Okay, this is option number 1. You can memorize little dude and it will make your life easier. Option number 2, you can choose to not memorize little dude, but you're going to have a good bit more work to show if you don't memorize little dude. Okay, it's gonna, and I'll show you what I'm talking about as I work through it. Okay, so just so you know, it's your choice. I won't force you to memorize little dude, but it will be to your benefit if you do. Okay, just say it. All right, so keep that handy, and I'll walk you through it here in just a bit. Conjugate zeros theorem, that's really, 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 really important. Okay, but it was on a video, so I'm not going to repeat myself. Let's just jump right on into example number 2. Are there directions in front of example number 1? No. Oh, but there's a sticky note. What's that sticky note say? Okay, so here's some tips on the sticky. Make a list of zeros. Hey, we know how to do that. We just did that in the last section. Number 2, turn all your zeros into factors. Hey, we know how to do that. We just did that in the last section. And then number 3, multiply your factors together. We didn't do that, but that's just boiling. Okay, so we know how to do it. So really, the math here isn't all that new. Okay, it's just kind of coming at it from a different perspective. So keep those in mind. So here we go. Example number 2. If 0 and 4 minus 3i are the zeros of a cubic, let's stop right there. What does tip number 1 say on that sticky? Say it again.
List the zeros.
Yeah, make a list of the zeros. Okay, so let's see here. We have zeros. What's my first 0 that I'm told? Okay, what's the proper way to write that? X equals 0. And you said, but Ms. Roberts, can't I just write 0 because I'm too lazy to write an X? Okay, that's fine. It will mess you up. Okay, and if it messes you up, I'm not going to feel sorry for you because I told you not to do it. Okay, I wouldn't count it wrong, but it will come back to bite you. What is my next 0? But how are we going to write it properly? X equals 4 minus 3i. 2 comments. What kind of a polynomial am I told this is going to be? A cubic. What's the degree of a cubic? 3. So how many zeros should I have? 3, but I only have 2. Go back to the theorem, the one that you had on the video, because your theorem will tell you what the third 0 is.
X equals 4 plus 3i.
Very good, both of you. Very good. X equals 4 plus 3i, because it says if you've got one complex 0, you have to have the conjugate as a complex 0. Okay, conjugates we did back in section 2.6. All right, so that's what that theorem says. Oh, good, now I have my zeros, and I have 3, which is what I expected to have. Okay, all right, what does tip number 2 on the sticky tell you to do? Turn them into factors. Okay, what's a way to write the first factor? Yeah, you could write x plus 0, you could write x minus 0, or you could write x. Because when you add 0 or when you take away 0, you get the exact same thing back, okay? So x would be the easiest thing to write. Now, remember what getting a factor, how we do that. It's basically we're moving all of the numbers over to the other side so that the x doesn't feel lonely, right? So let's do the same thing here. Let's move all of our numbers over to the other side so that x doesn't feel lonely. So what's my second factor?
X minus 4 plus 3i.
And is that what you said? I don't know. I couldn't tell who was talking. That was you. Is that what you said? Good. All right. So x minus 4 plus 3i. Very good. And then the third factor would be what? Yeah. And here's the deal. Okay, so I just got finished saying if you don't write the x, it's going to come back to bite you. Every time my students don't write the x in the zeros column, they forget that there's an x in the factors column. Every stinking time. Okay? So I'm strongly recommending, basically requiring, to write the x equals in the zeros column so that you don't forget it in the factors column. Okay? So don't be normal, be weird. All right. Now, let's see. So, okay, so we got zeros of a cubic. It says find the missing zeros. I did that. Okay, I already did that. Keep reading. And find the standard equation. The standard equation is the one that's the not factored form. You know, the one that looks like 17x to the fourth minus 5x cubed plus 3x squared minus 7x plus 4. That's standard form of an equation, okay? Go back to your sticky note. Tip number 1 was make a list of your zeros. Tip number 2 was get a list of your factors, turn your zeros into factors. What was tip number 3? Multiply your factors together. Okay, now we've already done this, sorta, at least the first step, in the last section. We said P of x is equal to my factor x times my factor x minus 4 plus 3i times my factor x minus 4 minus 3i. We've already done that part of it, okay? What we haven't done yet is we haven't started multiplying everything else. Okay, now, look up here. I'm going to show this on the screen so that the people on Zoom can see what I'm pointing at. If you don't have little dude memorized, what you're going to have to do is you're going to have to take your x and you're going to have to distribute it to the x, distribute it to the negative 4, distribute it to the negative 3i. And then you're going to have to take your negative 4, distribute it to the x, distribute it to the negative 4, distribute it to the negative 3i. And then you're going to have to take your positive 3i, and you're going to have to distribute it to the x, distribute it to the negative 4, distribute it to the negative 3i. And then you're going to have to combine all of your like terms, and then you're going to have to write it properly. And you better hope you don't make a small mistake in there somewhere, because if you make one tiny little error, the whole thing's wrong. Yeah. Okay. So what I've done is I've created little dude for you. Little dude helps multiplying these two together much more simple. Okay. So let's go back for just a second and let's look at what little dude says. Notice that the left-hand side of the equal sign looks a lot like what we're about to multiply with the 3's and the 4's in it. The right-hand side is what we want to memorize. Now, what are all the letters on the right-hand side? What letters are used? A's, B's, and X's, right? That's it. A's, B's, and X's. That's all we got. So what we're going to do before we get into multiplying little dude, by the way, have this handy because I can't show it at the same time. Have this handy, x squared minus 2x plus a squared plus b squared. Okay, have it handy. The first thing that we want to do is from the very beginning, when I was making my list of zeros, let's figure out what was my A and what was my B. Okay, so when you look at your zeros list, what's the A value? 4. What's the B value? 3 or negative 3. Now, it's not going to matter. Go look at little dude. What is it that you do to B? Well, you square it. So it won't matter if you square a positive or square a negative. You're going to land on the same thing. Okay, so you could say B is 3 or B is negative 3, and either one of those is going to be okay with me. Okay, all right, so now let's go use little dude. So we have x times, what's the first term in little dude? X squared. Okay, what's the next term in little dude? Negative 2x, ax, right? So we're going to have a negative 2 times a, what was your a that you decided? 4x. By the way, we're not plugging in anything for x. Okay, it's part of my polynomial. What's the third term in little dude? So basically what you just now told me is to multiply a squared. Is that what you mean? Plus a squared. Okay, I know, Miss Roberts, you're being so picky. Plus a squared. All right, so plus, what is your a squared? 16. Your a is a 4. You square that, you get a 16. What's your last term? Plus b squared. Okay, so plus, what is your b value squared? Yeah, remember your b value was either a 3 or a negative 3. Square that, you get a 9. Now, is doing, working with little dude, is that easier than all of that Mongo distributing you had to do? Yeah, that's why I say it is to your benefit to memorize little dude. I'm not going to require it, okay? But if you don't, you have a lot more work that you have to do, okay? Let's clean up little dude here. We've got x times x squared minus 8x plus, let's see, 16 plus 9 is what, 25? And then the last step that we'll need to do then is just simply to multiply or distribute the x into all three of those. So we have x cubed minus 8x squared plus 25x. So as long as you can tell, as long as you know what little dude is, this isn't so bad, okay?
Whenever you were multiplying like the standard third degree multiplication, what was that for? Or
Can you repeat the question?
like in the video with example 1,
Mhm.
whenever we did the standard multiplication at the bottom, what was that for? Or is this not done yet?
Oh, that was for the x plus 3 times the rest of it.
Are you asking what is this?
Yeah. What is
It is multiplying these two together. Sorry, these two.
Oh, okay, and since we just have 0 for this one, it's
Yeah, since I was only distributing an x, I didn't need to write it out like that because I was just distributing an x. This one I had to distribute 2 different terms. Does that make sense? Okay, good. All right, find the remaining zeros. Take a look at a phrase inside of the exercise. When you're told a number is a 0, what does that mean to you? Prove it. That's step number 1, okay? So you're told that 1 is a 0, go prove it. Don't do anything else until you've proven it. So what goes in the box? 1, yeah, because remember x, whatever x equals always goes in the box. All right, what are my coefficients? Okay. You got it, Becca. They just beat you because of the lag. That's the worst part about Zoom is there's a small amount of a lag. Okay, so let's go ahead then and do our synthetic substitution. So we have 1, 1, -4, -4, 13, 13, 0. Okay. Okay, so if it said, I'm not going to say anything. What should I do next? Look at the directions. What should I do next? Okay, factor. Why? Let's look at some things here. First of all, let's make a list of the zeros. We just proved that x equals 1 is a 0, right? We just proved it. Look at your depressed polynomial. What kind of depressed polynomial do you have? It's a quadratic, yeah, it's a square. Well, how many methods do you have for solving quadratics? 4 methods. Let's go use one of our methods. All right, now, what is my depressed polynomial? Okay, and we're going to set that equal to 0 because we're solving. So is factoring an option? Work through it real quick in your head. Yeah, no, it's not an option. It's not an option because the factors of 13 are never going to give you a 4. Okay, so factoring isn't an option. So if factoring isn't an option, as you look at that, what would you do next? And for the record, I might override you. Complete the square, that's what I would do, okay? Let me give you 2 good reasons for completing the square. 3 good reasons for completing the square. Reason number 1, I have a 1 leading coefficient. I only like to complete the square when there's a 1 leading coefficient. Reason number 2, my b value is even. Remember, you have to take half of b. I only like to do that when it's an even number. I can do it when it's an odd, but if I have a choice, I don't want to, okay? Reason number 3, if you have to take any further math classes, specifically Math 111, you're gonna have a whole entire chapter of nothing but completing the square on steroids. Okay, like it's gonna be X's and Y's. And we're not just gonna limit it to nice little pretty B's. Okay, so every chance we can get to practice completing the square will only help us in the long run. So I'm gonna complete the square. All right, so for those of you who would have chosen the quadratic formula just simply because it's plug and chug, that's the harder method. It's the harder method, okay? So let's remember, completing the square says, first of all, make sure there's a 1 for your A. We got that. Secondly, get the constant and throw it on the other side. So that 13, I don't want it there. Okay. So I've got x squared minus 4x. I'm going to leave some space so that I have room to complete the square, and the negative 13 will be thrown to the other side. Okay. So then we take half of b, which is, okay, technically negative 2, but that won't matter in a minute. And do what to that number? Square it, so that's going to give me positive 4. And then what do I do with that positive 4? Add it to both sides. So I'm going to add 4, add 4. Okay, combining the constants is no big deal. That's a negative, what, 9? No big deal. What is the step that I'm supposed to do with the trinomial on the left? Yeah, I'm supposed to factor. And remember, it's always going to be a pretty single quantity squared. If you did your completing the square correctly, it's always going to turn into this. That's the point of completing the square. So we have x, what's the rest of it? Minus 2. It was your half of b. So Dylan, I'm going to pick on you for a second. Remember when I said what's half of b and you just said 2? Now this is coming back to bite you because I corrected it. I said, no, it's actually negative 2, but that's not going to matter, but it matters now. So my half of b is negative 2. Okay, so now remember my goal here is to solve. Okay, I'm trying to figure out what my zeros are. And since I'm finding my zeros, that's the same as solving or finding solutions. All right, so now I'm gonna jump into, I'm finished with completing the square. How do I continue? What's the method that I use to continue? The square root method, yep. So let's take the square root of both sides. So that's gonna give me x minus 2 is equal to, what's the square root of negative 9? And tell me what I haven't written. I need a plus or minus. The square root of the negative is an I. The square root of 9 is 3. And then the last thing to get x alone is to add 2. And I'm writing it in standard form. So then I now have my second 0 is x equals 2 plus 3i. My third 0 is x equals 2 minus 3i. How many zeros did we expect from the very beginning? 3. Oh, good, we got them. Now, here's something else that's interesting. 2 of my zeros are what? What's the word? Okay, so they are conjugates, very good. What else are they? Yeah, they're complex. They're imaginary. If you had to graph them, you wouldn't be able to see them because they're in Mr. Rogers' neighborhood. Okay, they're at the imagination station. You can't see 2 of your zeros. So here, yes, I have a list of 3 solutions. I have a list of 3 roots. I have a list of 3 zeros. I actually only have one x-intercept. That first one is a true x-intercept, but the other 2, they're just in my imagination, okay? So they're technically not x-intercepts because you won't ever see them cross over the x-axis, all right?
Do you know what real world thing you could apply the imaginary stuff to?
So imaginary numbers lead into polar graphing, which is dealing with radius, plural, and angles, thetas. And so that's actually something that we get into at the end of Math 111. We take this whole concept of complex numbers, and then we take a shift and we use polars. And the cool thing about polars is that it allows us to start graphing things like spirals, or it allows us to graph what's called roses, but basically they're just like flowers with 2, 3, 4, 8, 16 petals on it. So taking it from complex numbers into polars allows us to graph some pretty cool stuff. That's the short explanation. Okay, good question.
I was just curious, what it was used for.
Yeah, that's the most short-term thing I can give you. There's way more down the line from that, but that's the short term. Okay, so number 4, I've already worked out for you, and it is very, very, very similar to the last question from the last section. The difference is that 2 of my zeros are complex, whereas in the last section I didn't have any complex. My suggestion to you would be to work number 4 on your own, okay, and see if you can get the same thing. If we have time today, I'll come back and I'll erase that and we'll work the problem from scratch. I'll let you guys work it out and then I'll show you. But if we don't have time, when we go back, you can take a picture of it, or on Zoom you can take a screenshot or whatever, and you can try that one on your own. Okay, so let's do a little bit of graphing in the calculator. So pull out your calculators. Sorry, this is, in one of my updates, things got messed up and I've never gone back to fix them. Okay. Now, we're not going to graph all 3 here, and I don't want you graphing yet. Okay, so if you've already started, put it down, because I want to do a couple other things first, and then we will come back and we will graph. So what I want to do is I want to list the zeros for the functions. We can do this without the calculator. Okay, so let's take a look at P of X. Do you see how P of X is already in factored form for you, right? So you know your factors. It's really easy to get your zeros if you know what your factors are, okay? So what would be one of the factors for P of X? Yes, but if you keep writing it like that, it's gonna come back to bite you. So what's the better way to write it? Very good, X equals -3. Okay. And someone else, what is another factor for P of X? Yeah, X equals +2. I mean, just because it has a square on it, think about what that really means. It just means that it's an X plus 3 times an X minus 2 times an X minus 2. Okay, so that's all that means. And once I list it as a 0, I don't need to list it again. All right, but I will take care of that here in just a minute. Now, it does say that we're going to be graphing these. Okay, so there's some things that we can do by hand. Let's go ahead and put our zeros on our graph for P of X. So let me find P of X. So it's over here on the right. So we have an X equals -3, and we have an X equals 2. Those are my zeros. Now, while we're here, be careful at the next question I'm going to ask you because I'm trying to trick you. Okay, so be careful. What is the degree for P of X?
Two.
Okay, so we've got some varying opinions.
So that's something that you could find by multiplying the factors.
If you want to. So the question on Zoom, the question was, can I find it by multiplying my factors together? Yes, you can if you want to. Okay. All right. So basically the two choices we've got, is the degree going to be 2 or is the degree going to be 3? Okay. Okay. I understand why you would say 2 because it's the highest power, right? But folks, that's when your polynomial is in standard form, not when it's in factored form. Think with me about a quadratic, right? Let me just do this on scratch paper right here. Think with me about something like P of X is equal to X squared, I don't know, minus, let's do minus 4. Okay, factor that for me. Because I chose an easy one to factor. It's the difference of squares. Yeah, x plus 2, x minus 2. If you look at this version, what's the degree? 2. But do you see a highest power of 2 when it's written in factored form? You can't see it. You have to think through it. Like, if I were to multiply it together, what would my highest power be? Okay, so that's what you have to be thinking through when you get to this one. If I were to multiply it through, what would my highest power be? It would be a 3. So this has a degree of 3.
Can you do a shortcut by like what it is written in that factor form? If you take that square and see it as x squared and then plus x to make that x to the third.
Well, okay, so let me correct your words a little bit. X squared plus x is not x cubed. Okay, so so Dylan, I'm not going to answer your question. Let's see if you're right by the time you get to Q of x and R of x, and let's see what happens with that. Okay. Okay, the last thing I want you to think about is if you have a degree of 3. What's the end behavior? I'm just reviewing some things. What's the end behavior for a degree of 3? 1 up, 1 down, right? Should I be going overall uphill or should I be going overall downhill? Uphill. Yeah, so a degree of 3 is going to look something like this. Okay, so again, I'm not ready to be graphing yet, but I do know I'm going to start somewhere at the bottom and I'm going to end somewhere at the top. Okay, just because of all of the things that I know so far about degrees of 3. All right, now, still not graphing. Let's go to Q of x. Okay, here's what I want to do. Let's divide and conquer here. I've got 2, 4, 6 in the room and 2 on Zoom. So what I want is Mary Alice, November, Dylan. I want you guys to take Q of x, and I want you to do all of the same things that we just did with Q of x. And I want you to do that, or that we just did with P of x, and do it with Q of x. And joining you from Zoom, let's see, Justin, I want you to join those 3. So Justin, you're working with Q of x. All right, then I want Devin and Abigail and Sierra and Becca. I want you guys to work on R of x. And I want you to do all of the same things that we just did to P of x. I want you to do that with R of x. So you're looking at finding the zeros, go put them on the graph, think of the degree, think of the end behavior, basically those 4 things.
Did you say I was Q of x?
I did.
Okay, I thought you said C of x.
Sorry, yeah, Q.
One thing I don't really understand is like the bracket things that just describe it.
I will talk about that in just a minute.
Because see that on my lab map.
Yeah, it's domain and range.
Okay.
That's all it is. And domain always comes first, range always comes second. But I'll talk about it here in just a second. So you're looking for zeros, put them on the graph, degree, and end behavior. Check with each other. That's a little harder on Zoom. Sorry about that, guys. Okay, Q of X people, you guys haven't checked with each other yet. Don't ignore me. And Justin, feel free to chime in if you would like to. Mary Alice is in your group too, Dylan. Oh, he was, okay. Becca, if you wanna collaborate with your group, go for it. Oh, she says something. All right, so she says degree of 6. Is there more in there?
No, that's all I got so far. Well, I have more, but.
You guys agree with her? They agree with you, Becca. So can you read that? Her, she's listing her zeros. Question mark. I love it. So how do you respond, so Becca?
Yeah, that's what we all have.
They're saying they got the same thing. It's gonna be a little harder to draw the end behavior though, Rebecca.
Oh, yeah. Normal parabola.
Who needs the chat for that? Justin, you wanna chime in with your group? Yes, no?
Oh, I'm stuck. Wait, I'm still working.
Okay. She's right. Well, multiplying like bases tells me to add the exponents. That's what the rule says. Good. All right, so let's take a look. I know that we haven't done everything that we're supposed to do yet for each one of these, but let's go to Q of X. So the Q of X group, what did you guys get for your zeros? Okay, interesting. So so far it looks exactly like the P of X graph. So far, right? Okay, so Q of X group, what did you guys get for your degree? Degree is 5. So we're thinking here the fact that an x squared times an x cubed would be an x to the 5th power. So that's how we get that, and I agree. So what's the end behavior of a degree of 5? Interesting. So far, those two graphs look exactly the same. Maybe they really are the same. We'll find out. Okay, we'll see. All right, now, R of X group. What did you guys find for the zeros? So almost exactly like the other two groups. The difference is that x equals 0 part. So let's go put that on our graph. So we've got a 2, a -3, and 0. So that's going to be at the origin. All right, and then for r of x, what was your degree? Degree was 6. And again, when you think about your powers, you've got a power of 2, a power of 3, and an imaginary power of 1. Okay, or I shouldn't say imaginary, that might be confusing. An unwritten power of 1. And so an x squared times an x cubed times an x to the first is going to be an x to the 6th power. All right, what's the end behavior on a degree of 6 for this guy? Say it again. Yeah, good. So both ends are going to be up. So this graph is definitely going to be different than the other two graphs. Okay. All right. Now let's go put P of X into the calculator. So take your calculator out, turn it on, go to your Y equals and type it in exactly the way you see it. So quantity x plus 3, close your parentheses, quantity x minus 2, close your parentheses, square it. Don't graph yet. Don't graph yet. Just enter it into the Y equals. Now, before you graph, go to your window. Go to your window. This guy here, the first piece is your domain. So these are your x min and max. Okay? And then the second guy is your y min and max. That's your range. Now, if your y is going to be that stretched out, I would probably use a y scale of like 5 maybe or 3. What that means is that it's only going to put a tick mark every 5 units, all right, instead of every 1 unit. So like for -10 to 10, it's no problem to have a scale of 1. It just puts 10 tick marks on each side. But for the -30 to +30, that gets a little funky. Okay, now once you have your window in there, go ahead and push graph. Now we need to duplicate this, but I want to ask you first, everything that we have on our graph so far, does it match what's on your screen? It does, yeah. Okay, so we're gonna start down here at the bottom. Okay, because we move from left to right, so we're going to start at the farthest to the left piece that we have, and we're going to come up to that first 0. Now, when I start coming up to that first 0, tell me, am I going to like go right through that first 0, woo, right through it, or am I going to bounce off of it? I'm supposed to go through that 0 according to what's on your screen, right? I'm going through it. I'm not even worried about the y-axis. Okay, I'll show you what I'm going to do. Just wait. And then the next thing that I care about is that I need to deal with my 2. How do I hit the 2? Do I go through the 2? Or do I bounce off of the 2? I bounce off of the 2. And then I bounce off and keep going up forever and ever. Does your graph kind of look like that? Okay, right now, I don't really care what's on the y-axis. I'm not going to put a number there because right now I just don't care. What I really want to know what's happening right now is what's happening at those zeros, at those x-intercepts. That's what I really want to know. Okay, now let's take a look because I didn't answer some of my questions. My second question was to state the number of repeats for each 0. That's called a multiplicity. Okay, so at P of X, how many x equals -3s did I have? How many of those zeros did I have? There was only one of those, so my multiplicity is 1. And how many x equals 2s did I have? There was 2 of those because it was squared. Okay, I'm coming back to that. All right, now Q of X group, I want you to do the same thing. I want you to go graph your graph. And R of X group, I want you to graph your graph. Pay attention to the different window. Pay attention to the different window. After you get your graph, go figure out what your multiplicities are. Show each other your graph. And then talk through your multiplicities. By the way, your graphs should be identical to each other's if you use the window you were told to use. Get your graph, get your multiplicities. Yeah, remember your governor? Show it to Becca, is this what you have for a graph?
Yep.
Okay.
Oh God.
That's okay. I'll just let you. Justin, is that what your graph looks like? Justin, did you change the window? Your window should have been -4 to 4 and -125 to 50.
So I changed the scale.
So I'm not sure if you have the right graph with the wrong window or if it's just the wrong graph. Yeah, that looks better. Yep. Okay, so I'm looking at, let's go look at Q of X. So you guys over on the other side, you didn't graph Q of X, so let's let our Q's describe to us what the graph looks like. So we're starting down at the bottom. We know that because of the end behavior. When I get to the x equals -3, do I go through it? Do I bounce off of it? How do I act with it? I bounce off of it, okay? Like this, so far, all right? And then when I get to 2, when I get to the 0 of 2, do I go through it or do I bounce off of it? So I go through, but I go through slowly. It's not like the last one where I just went, whoo, right through it, right? I kind of level off and then I still continue to go through. Okay, so something like, if I'm understanding something, there's a leveling off and then it kind of goes like that. Would you agree? Okay, so you guys can graph that then. With the multiplicities Q group, What was the multiplicity of the first 0, x equals -3? A multiplicity of 2. How about the multiplicity for x equals 2? 3. Okay, we're going to come back and we're going to figure out what do these multiplicities tell us about a graph. Okay, so for the R group, we know that we have to start up here. Okay, so R group, tell me when I'm at the top and I'm going to come down and meet that 3, how should I react to that 3? Should I go through it? Should I bounce off of it? What am I going to do? So I'm not bouncing, I'm going through it, but are you telling me I'm going through it slowly? Okay, all right, so in other words, I'm leveling off. Is that kind of what you're talking about? Okay, all right, so I'm still going through it, but it's not like the P of X graph where I just went, whoo, straight through it, okay? All right, and then the next 0 that I have to contend with is the x equals 0, the one at the origin. So how do I react to the one at the origin? Do I go through it or do I bounce off of it? Bounce off of it. Okay, so I'm going to come up and bounce off, something like this. Okay. And then last but not least, how do I react with the x equals 2, 0? Straight through, no leveling off. So something like this. Would you guys agree? Okay, it's not gorgeous, but something kind of like that. And again, I don't really care right now what my y's are doing, okay? Now, what were your multiplicities for the R group? What's the multiplicity for x equals 2? And the multiplicity for x equals -3? And for x equals 0? 2. Now let's put this all together and figure out what it all means to us. Because down at the bottom of this page, I'm talking about the even multiplicities and the odd multiplicities. So what I want you to do, I'm going to turn my screen here. What I want you to do is look at all of the even multiplicities on all 3 graphs. Find the even multiplicities on all 3 graphs. What do all the even multiplicities do on my graph? All of the even multiplicities. So there's one right here. There's one right here. There's one right here. All of the even multiplicities bounce. Yeah, Devin?
Would x to the 4th still look like that, or would it do something a little different?
Good question. Can I answer that as soon as I do the odd multiplicities? Because that's actually going to tie into your question. Now, let's go look at the odd multiplicities. I have more than one. For the evens, I only had a multiplicity of 2, so that's going to lead into Devin's question. Look at the odd multiplicities, and what do all of the odd multiplicities do? They go through, but they go through differently, don't they? The one that's just a 1 goes, whoo, straight through it. But then the higher the multiplicity, the slower it goes through it, right? So Devin, to answer your question, what if I had a multiplicity that was even, but it was something higher, like a 4? It would still bounce. It would just take longer to bounce. So it would almost be like a parabola that's been dropped. Okay, it's a little flatter. It's still bouncing, but it's a little flatter. Okay, so the higher the multiplicity, the longer it takes to do the job. And so odd multiplicities intersect the x-axis. And the word that I'm going to use for that, they're breakers. They break through. So I have bouncers and breakers. Again, these are Robert's terms. If you go to the TLC and talk about bouncers and breakers, they might not know what you're talking about.
So would be the technically correct word.
Even ones are going to, you're going to love this because you will see this on my lab. It'll say something like, they touch the x-axis, but they do not intersect. Isn't it a lot easier to say it's a bouncer? Yeah. Okay. But that's what's happening. They do touch the x-axis, they just don't intersect the x-axis. Okay. So, example number 5. Find P of X with the given zeros. Let's stop right there. If you're given zeros, what does that mean to you? Prove it. Okay, this isn't any different from what I've been doing. Leave in factored form is what it says. Okay, so let's go ahead. Let's do what we've been doing. Let's make a list of zeros. So tell me what I have for one of my zeros. Good catch. X equals 1 plus 2i.
X equals 1 minus 2i.
Okay, x equals 1 minus 2i. Becca, where did you get that one?
The conjugate.
Yep, the conjugate zeros theorem. Okay. Mary Alice, what were you saying? That was you, November. Sorry. Go ahead. What were you saying, November?
X equals 2.
X equals 2. Is that all of the zeros I have? If you said yes, I would say, okay. If you said no, I would say, okay, but I would still, technically there's another x equals 2 because there's a multiplicity of 2. Okay, so really how many zeros do I have? Technically I have 4. Okay, technically I have 4. So what would my degree be? 4. If you're only looking at that list though, what does your degree appear to be? It looks like it's just 3. So you have to be careful about that, okay? You don't have to list another one, but you do need to realize that there are duplicates, okay? I'm supposed to leave in factored form. I'm supposed to find P of X. The only way to find P of X is to multiply my factors. The only way to multiply my factors is if I have factors. Okay, so let's take all of our zeros and let's turn them into factors. So my first factor? No, minus 2i. Yeah, because you want to take all the numbers over to the side with the x. Good catch on that one. And then the next factor? And the next factor. And I'm going to disagree a little bit. Squared. Because of that multiplicity of 2. Okay, so then let's go get our P of X. So remember, P of X is where we write down our product of factors. So we have x minus 1 minus 2i. We have x minus 1 plus 2i. And we have x minus 2 quantity squared. You guys will have to help me out with this next question because I don't know the answer to it. Because I haven't done the MyLab homework in several years. So you'll have to help me know what's in my lab. I don't think, even though it says leave in factored form, if I was giving a test on paper and I said leave in factored form, this would be an okay answer. I would be fine with this. Okay. I don't think that my lab accepts this as factored form as long as there's i's in there. So I believe, and again, you'll have to let me know as you're working through the assignment, I believe it requires you to multiply these two together. But we can use little dude for that. That's not hard. Okay. So, but before I do little dude, let's make sure we have our right A and B. What is our A? 1, and our B? Yeah, and you could say 2 or negative 2, and either one would be okay. So again, I'm just trying to be consistent with what I think my lab requires. So this first quantity then, what would be the first term? Remember, what's the second generic term? Minus 2x. So minus 2, what's my a? Oh, I'm not going to write that. Times my x. 2 times 1 times x, right? What's my third term? Which is plus 1. And what's my fourth term? And that is 4. So we'll clean that up, and then it will be in factored form. So we've got x squared minus 2x plus 5 times x minus 2 quantity squared.
If it said simplify, would you have to do that?
Yeah, if it said, instead of saying leave in factored form, if it said to get in standard form, that's how it would word it, get in standard form, then what you would have to do is, the first thing is you would have to FOIL out this piece. Okay, so it would be an x squared minus a 4x plus a 4 or something like that. And then you would take this trinomial times this trinomial. Okay, and in the video, the easiest way to do big polynomials like that is to do it this way, where you write one over top of the other. That really is the easiest way to do that kind of a distribution, in my opinion. You can disagree and I won't care, okay? But in my opinion, that's the easiest way. How am I doing on time? I got 5 minutes, lovely. All right, draw a sketch without a calculator. Oh, good. Well, I think we know enough information now that that's not too hard. Okay. Can we make a list of our zeros? And see, they were nice to us. They gave us the factored form. So what's our zeros?
X equals negative 2/3.
Good. X equals negative 2/3.
X equals negative 1.
Yep. And?
X equals positive 2.
With?
2 multiplicities.
Yeah. And actually, let's just go ahead and make a list of all of our multiplicities here. So the multiplicities.
1, 1, and 2.
This one is a multiplicity of 2. What are the multiplicities for the other two?
1.
Yeah. So what does that tell us then? Before we even start drawing the graph, a multiplicity of 1 tells us it's a what? Okay, I'm going to call that a breaker. And a multiplicity of 2 tells me it's a bouncer. So that helps me to know what my graph is going to be doing. All right. Before I move further, can you tell me about the end behavior? Both ends up. My degree is 4. My leading coefficient is positive. Okay, so let's head over to our graph then. Let's see, I can spread it out. Since it says a negative 2/3, I can kind of spread things out if I want to. Yeah, let's do, so I'm gonna go by 3 blocks. 3 blocks is 1 unit. That'll help me to graph 2/3. So x equals negative 2/3 is on this side. X equals negative 1 is also on this side. And x equals 2 is over on the other side. Okay, now we're not, remember this is a no calculator question. You said that both ends are gonna be up. Now I have one more question before I start graphing. What's my y-intercept? Yeah, remember that y-intercepts are where your x's are 0? So if you look at the first polynomial and you plug in a 0 for all those x's, you're going to get just a positive 8 for your y-intercept. I'm not going to draw that yet. I'll show you what I'm going to do. Okay, so let's come down to the first 0. When I come down to the first 0, and am I going to break through or am I going to bounce off of? Break through. Okay. When I get to my next 0, the negative 2/3, breaker or bouncer? Breaker. And then when I get all the way over to my last zero, the x equals 2, break or bounce? Bounce. What did you say that your y-intercept was? 8? Okay, so take wherever you crossed over and call it 8. It's easier than counting 8 blocks and trying to hit that number.
Crossed over in a spot where it actually makes a decent problem.
Right. Okay? So now we can do all of that without the aid of the calculator. Now, I didn't finish. Let me tell you something. The next section, okay, from here to the end of this set of notes, this is the climax of the entire semester. I feel like this is the whole, everything we've been doing so far is leading up to this point right here. Not only is it the climax, I feel like it's the most tedious. Go back and watch these videos. This is a big deal. Okay, so before class next time, watch these. Start getting an understanding. All right, before class next time. Have a good weekend. See you on Tuesday. Bye, guys.